This lesson is on the 6 trig functions, and before we get started, we're going to talk about some Greek letters. I have some Greek letters listed here, and the reason that we're going to talk about those is because a lot of times with trig and with upper level math, they use Greek letters to represent the angles inside of the triangles. They're still going to use your standard English letters to represent other things, but typically with angles, and especially when you're using trig, they're going to focus on these. This one that looks like kind of an O with a line through it is theta. One that you'll see that kind of looks like a little fish is alpha. Your beta just looks like a B with an extra long tail. Your gamma kind of looks like a funky Y, and then phi or phi looks like an O with a line through it. If you see the uppercase one, which they typically don't use with angles, it has kind of an I shape with a circle on it. But again, all of these are Greek letters used for angles. Okay, and now we're going to get into labeling triangles and talking about how we identify parts of them for trig. So here I have two triangles, and they look like they're right triangles, but to be sure, you will find a little kind of box in the corner. The little square box means that is a 90-degree angle. It is a right angle. And now you cannot do, in the situation we're using today, you cannot do trig functions with the 90-degree angles. Later on, we're going to get into some things that get a little more in depth. But we're going to be focusing on the acute angles. And so let's name one of these acute angles theta in this first triangle. And it is important to look at the angle, the acute angle that you are dealing with, so that you can determine what the sides are. Now, I always determine which one my hypotenuse is first. The hypotenuse is the side that is located across from your 90-degree angle. And so wherever your 90-degree angle is, look across from that, and that side is your hypotenuse. And then I'm going to, again, refer to that acute angle for the other sides. The first one I find is the opposite, because I can go from that angle across, like draw my finger straight across, and that side is your opposite side. The side that's left, or that you would have to like curve your finger to, is your adjacent side. So if you find your hypotenuse first across from your 90, and then your opposite side second across from the angle that you're talking about, the side that's left has to be your adjacent side. So I'm going to take that same look to the triangle, but I'm going to focus on the other angle. Let's say that this one was theta, this acute angle up here. The hypotenuse wouldn't change. It's still across from the 90-degree angle. But the other two sides would, because they are found in relationship to the angle you're looking at. So if I'm looking, this is theta, I draw straight across, that would be my opposite side. And then if I had to curve, or just the side that's left, that is your adjacent side. Alright, so why have we labeled all of these? We've labeled those because the 6 trig functions that we're going to be dealing with, sine, cosine, tangent, cosecant, secant, and cotangent, those all are named based on these sides. Now, when I'm writing these in your notes, I kind of use just the first letter. So like for opposite, I use an O. For hypotenuse, I use an H. For adjacent, I use an A. So that's an easier thing to look at. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And we're just making little ratios out of those. We'll get more in depth with these later, but we're just determining what those relationships are today. The three, cosecant, secant, and cotangent that are left, those are just reciprocals of the first three. So I've paired them up. Sine and cosecant are partners, cosine and secant are partners, tangent and cotangent are partners. And it's always going to work like that. Notice for the first two, everybody wants to to mix them up, but it's always an S and a C together. So sine starts with an S, cosecant starts with a C, cosine starts with a C, secant starts with an S. A C and an S pair up. And those are easy to find once you've found the first three. It just is the flip. So cosecant being the flip of sine will be hypotenuse over opposite. Secant will be hypotenuse over adjacent. And cotangent being the flip of tangent will be adjacent over opposite. Now, there are several different ways to memorize these. Most people just focus on the first three because the second three are just flips of those. There's lots of sayings. One I like is, oh heck, another hour of algebra. There's some, focusing on the S, old horse, caught another horse, taking oats away, using those first letters, or some old hippie, caught another hippie, tripping on acid. There's lots of different ones you can find on the internet, but again, I tend to focus on, oh heck, another hour of algebra just because it's quicker. And the sine, cosine, and tangent, those I always list in the same order that they're listed on your calculator, and that should line everything up for you. So those are something you have to memorize. You're not going to be given those. Everybody that's working with trig is going to know those. So take the time to memorize one of those sayings or just memorize those words. Okay, so for our first example, we have find the 6 trig functions of alpha and beta. So I have a right triangle here. My acute angles are alpha and beta. My sides are all labeled 5, 12, and 13. So I'm going to answer what the 6 trig functions are for alpha, and then I'm going to ask you to pause and try beta for yourself. So let's get started. The first thing I do is write down in order what I'm finding. So sine alpha, cosine alpha, and tangent alpha. And then I'm going to make sure I pair the C and the S, so cosecant alpha, secant alpha, and cotangent alpha. And so once I have it all set up, all I have to do is look for the sides that I need. So sine, I've memorized, is opposite over hypotenuse. I'm looking at the angle alpha, so that's this top one. So my opposite side that I can draw my finger across to would be 5. My hypotenuse is the 13 because it is opposite of the 90 degrees. So my sine would be 5 over 13. I don't even have to think about cosecant, I just have to flip the sign. So that would be 13 over 5. Then my cosine of alpha, cosine is adjacent over hypotenuse. So I've located my adjacent side to be 12. My hypotenuse is 13. So 12 over 13 for cosine. And again, my secant is the flip of that, so it will be 13 over 12. Tangent, I've memorized to be opposite over adjacent. And so opposite of alpha is 5, adjacent is 12. So 5 over 12. And then for cotangent, I'm just going to flip that. And so those are my 6 trig functions for alpha. At this time, hit pause and try to do beta for yourself. Okay, let's check your answers. So for the sine of beta, you should have opposite of beta, which will be 12 over hypotenuse 13. So cosecant would be 13 over 12. For cosine, you should have adjacent, which would be 5 over the hypotenuse of 13. So 5 over 13, secant would be 13 over 5. Tangent would be opposite over adjacent, so 12 over 5. Cotangent would be the flip of that, 5 over 12. Hopefully you did well with those. Okay, I want to take a moment and talk about your reciprocal functions. Because they partner up and they're the flip of each other, you can also write them as cosecant is 1 over the value of sine, secant is 1 over the value of cosine, or cotangent is 1 over the value of tangent. These are going to come in handy later, but I wanted to go ahead and throw them in right now because I wanted to show you that they're still pairing up as partners. it's really just a flip once you do the math for these things, but again, these are going to come up later, but I figure it's a pretty helpful thing to go ahead and put it down in your notes and note that those relationships, the C and the S, the cosecant and sine, secant and cosine, still pair up, and cotangent and tangent still pair up. All right, we're going to go to another kind of example here dealing with these ratios, and they're actually already going to give us some of those. So given that sine phi is 4/5, cosine phi is 3/5, and tangent phi is 4/3, find cosecant phi, secant phi, and cotangent phi. So this time we don't have a triangle to look at, but we don't actually need one because they've given us the three primary trig functions, and the others are just the flips. You just have to pair them correctly. So cosecant phi, let me try that again, is the flip of sine. So if sine is 4/5, cosecant is 5/4. Secant phi is paired with cosine. So if cosine is 3/5, the secant would be 5/3. And then finally, cotangent is paired with tangent. So to find the cotangent of phi, I would just flip the tangent, which would be 3/4. And so this is another simple kind of problem, but you don't actually even have to draw a triangle because everything you need is there. You just need to flip the primary values. Okay, for example 3, it's really similar to example 2. I mean, in fact, it reads pretty much the same. You're given the sine, the cosine, and the tangent, and asked to find the cosecant, the secant, and the cotangent. The difference is, in this case, we're going to have a square root. And when you have a square root, you may have to rationalize the fraction that you get because we don't have square roots on the bottom of fractions in this course. So, for example, if I want to find cosecant of gamma, then I'm going to flip the sign, which would be 5 over the square root of 21. And that square root ends up on the bottom, and we can't have it there. So to rationalize that, we are going to multiply by the square root of 21 over the square root of 21, which is going to give us 5 square root 21 over 21, because on the bottom you would get 21 squared and the square and the square root would cancel, so you can actually just go ahead and realize that it's 21 from there. But anytime you have a square root, you do want to do this if it's on the bottom. Sometimes you will actually be working out a problem, you'll get a square root, make sure that you have it in the most reduced form before you start rationalizing, otherwise you're going to have to reduce at the end, and so you want to start with the most simple form that you can. So that is the example of how we would do cosecant. Now for the secant of gamma, you actually don't have to worry because there's no square root in that. You can just flip it, and that would be 5 over 2. But then again, when you get to the cotangent of gamma, you would end up with flipping that, and it would be 2 over the square root of 21. And again, you would have to rationalize. So I'm going to multiply by the square root of 21 over the square root of 21, which will be 2 square roots of 21 over 21. And the 2 and the 21 don't reduce here, just like the 5 and the 21 didn't reduce here because we were already in our simplest form. So just this problem is put in here as a reminder, if you have square roots, you do have to rationalize, you do have to simplify. We don't want decimals in these trig ratios right now, so this is the best way to answer. Okay, before we go on to our next problem, we want to talk a little bit about similar triangles. Similar triangles may be something that you have experienced in a previous math class, which you should have talked about. And if you remember, one of the important things about similar triangles was that corresponding angles, in other words, the matching angles, have the same measure. Their sides are related as well, but we're focusing on angles today, and so this is the important thing that we want to remember. So let me put some numbers on this. Okay, so I've got some numbers on here, and I chose a 3, 4, 5 because that's a really easy and typical Pythagorean triple. That means it always works on a right triangle here. Or a right triangle will always be formed by those side lengths. So I have two similar triangles. one is smaller than the other. That's generally what happens with those. But notice the angles are marked the same. You both have a 90-degree, then both of them have alpha, and that's representing the fact that they are the same measure. And then both have a theta. This one's lost its little cross, but those should be the same measure as well. So if the angles match up like this, even though they're different sizes, those are considered to be similar. Now, I said there is a relationship between the sides, and I'm just going to touch on that. If you'll notice, the ones that match up, the 3 and the 12, the 4 and the 16, the 5 and the 20, if you multiply the 3, 4, and 5 by 4, you do get the 12, 16, and 20. So basically, you've multiplied this triangle by 4 to get this triangle as far as sides go. And so that does have an effect on what we're doing because we are making relationships out of the sides. So let's put something down about that. So for our focus today, what we want to say is that for similar triangles, the trig ratios are the same. Now, what do I mean by that? So, if I did, say, look at the little triangle, if I did the sine of theta, the sine of theta would be opposite over hypotenuse, so 3 over 5. Now look at the big triangle and do the sine of theta. So that would be 12 over 20. But what does 12 over 20 reduce to? 3 over 5. So the ratios end up being the same once you reduce. So similar triangles have the same trig ratios. You just have to remember to reduce. Okay, for our last example, we're going to have a situation where some information is missing. If sine of theta is 6 over 7 and theta is an acute angle, find the other 5 trig values of theta. So we don't know everything in this triangle. Let me get a triangle here because we're going to need to draw one. Okay, so I've got a triangle here. I am using theta as an acute angle, so I can pick either the top or the bottom. I'll just pick the bottom. This is obviously my right. And when I have a sine, I know that this top number is the opposite and this bottom number is the hypotenuse. So I know my hypotenuse is 7 and my opposite side is 6. What I don't know is this bottom side here, and that's where the extra work comes in. I have to use Pythagorean theorem. So for a minute I'm going to call that x because I don't know that side, and I'm going to do Pythagorean theorem to find out what that is. Keep in mind that when you do Pythagorean theorem, your two sides that you square and add together should always equal the hypotenuse, whichever way that you write it. So I'm going to write x squared plus 6 squared equals 7 squared. And there are times when different things will be missing, so just be careful with the order in which you do this. So x squared plus 36 will be 49. If I subtract 36 from each side, x squared is going to be 13. Then I will take the square root, so x will be the square root of 13. So now I know what x is. I'm going to label that and actually work the problem. Okay, so I have labeled that as the square root of 13, and I am going to now figure out my other functions. We know the sine, and even if we hadn't drawn the triangle, we should know the cosecant, just because those are the reciprocal relationships there, giving us that. I did have to do the other stuff to get the remaining 4. So if you're asked for these, you can at least get one of them without drawing. I do need to find the cosine of theta and the tangent of theta, the secant, and the cotangent. So I go back for my cosine, I need adjacent and hypotenuse. So adjacent is square root of 13, hypotenuse is 7. And then for my tangent, I have opposite over adjacent, so that would be 6 over the square root of 13. Again, this is one I have to rationalize. So if I have 6 over the square root of 13, I have to multiply by the square root of 13 over the square root of 13, which would give me 6 square roots of 13 over 13. Now for secant, I'm going to flip my cosine, which would be 7 over the square root of 13. And again, I have to rationalize because I end up with a square root on the bottom. So I'm going to multiply by the square root of 13 over the square root of 13, which is going to give me 7 square roots of 13 over 13. And then finally, when I'm looking at my cotangent, if I flip the one where I had rationalized, so if I flip that final answer, I'm going to have to do more work. I'm going to have to do more rationalizing. So when you are just looking to flip, I would go back to that original one and flip it. So I'm going to look at the 6 over the square root of 13 and flip that. That way I don't have to do a bunch of extra work and reducing kinds of things. And so that's about as hard as it's going to get with this lesson. We will get into more in-depth things to come in the future lessons, but that concludes this lesson for today.